In this, we're looking for the x, y, and z that will satisfy all three equations. And we're going to find this using substitution. Let's get started. When I start with one of these problems using substitution, I look at all three of the equations and try to determine which one would be the easiest to get a variable isolated, solve for the variable. It looks like equation number 1 is very easy to solve for any of the variables. I could solve for x, y, or z. So then I consider which one is the best one to solve for to make my substitution the easiest. To determine that, I look to see what is the easiest one to substitute something for in the other two equations. So if I'm going to isolate x, y, or z and solve for that, I'm going to look at equations 2 and 3 to determine where is it going to be most easily substituted. If I substitute for x, notice I'll have to multiply everything by 2x, or by z, I'll have to multiply everything by -3. That kind of distribution just leads to potential for errors. So I like it better when I choose something that I substitute and I don't have to do any distribution, like for these y's. Yes, I'll have to distribute a negative sign, but I don't actually have to distribute any numbers. So that's how I've determined I'm going to solve equation 1 for y. So when I solve equation 1 for y, it's very simple. I'm just going to move everything else over. So that's going to give me 11 minus x minus z. And that is my solve for y, and that's what I'm going to use for my substitution. So now I'm going to substitute this in the place of y in equations 2 and 3. So let's go ahead and do that now. When I substitute this for y in equation 2, this is what I get. I'll get 2x plus my y, which is this 11 minus x minus z. Then I still have the minus 3z, and that's going to equal -1. So now I'm going to just solve, or simplify, I suppose. I'm not going to solve for anything yet. So I combine my x's. I have x, and then I have -z and a -3z. So that gives me a -4z. And I have this constant 11. I'm just going to move that to the other side to be with the other constants. So I have equals -12. So that's where I'm at on equation number 2. Okay, that's where that one is. Now I'm going to look at equation number 3 and substitute for my y in there. So that will give me x minus, now I have to be careful here because I'm substituting for the y and this minus sign is going to apply to all of it. So I am going to put that in parentheses. 11 minus x minus z. Remember that was what y equals, that's our code. Plus the 2z equals 20. Now I need to distribute this minus sign to see what I have, and that will give me a -11, a positive x, and a positive z, because this negative sign just changes all the signs that follow. I still have my plus 2z and my 20. Let's see if I can squeeze this in here. I'm getting close to the bottom. I have 2 x's. Can you see that? 2x. And then I have z and 2z, so that's a positive 3z. And when I move this 11 over, I get equals 31 because I added 11 here. Okay, so that's my equation 3. So now that I have new equations 2 and 3, I'm going to look at those and I'm going to consider which one is the easiest to use substitution again. My first step is what is the easiest thing to solve for? So in this equation 2, I have x minus 4z equals -12. And in equation 3, I have 2x plus 3z equals 31. Well, the easiest thing to solve for is obviously this x. I can get that x by itself pretty easily by just moving everything over. So that will give me x equals -12 plus, can you see this, 4z. So that's my new x. Now I can substitute this x in to my equation 3 and see what we get. Let's take a look. So I'm using equation 3, which is 2x, but instead of x, I'm going to write what my x equals, which was negative 12 plus 4z. That was my 2x plus 3z equals 31. Now you see I have an equation that is all in terms of z. I can solve that. I'll distribute my 2, which will give me negative 24 plus 8z plus 3z equals 31. Continuing to solve, I have 11 z's. And if I move this constant over to be with the other constant, I get 11z equals 55. I like where this is going. I divide both sides by 11, and I find that z is 5. And we have found our first solution. Z in all of these equations is going to be 5. Now I'm going to work my way backwards to find out what x and y were as well. So looking back over my previous work, I can see right here that I have an equation for x. So x is negative 12 plus z. X is negative 12 plus 4z. But now I know what z is. It's 5. So that means x is negative 12 plus 20, or x is 8. And now I have 2 of the 3 figured out. To find my third one, I can go back to this first substitution I made, which was y equals 11 minus x, which we cleverly deduced to be 8, minus z, which we found to be 5. 11 minus 8 is 3, and 3 minus 5 is negative 2. So there is my third solution. That means the solution to the system of linear equations is x is 8, y is negative 2, and z is 5.